Welcome. This is going to be a short video. There's going to be two videos here. Together, they're going to cover the beginning of chapter 8.1, which is the beginning of unit 3 on modern symbolic logic. So this first video is going to be just 5 to 10 minutes probably. It'll be over logical operators. And then part 2 will be over the truth tables. All right, so let's start this out. What we're looking at is the difference between categorical logic and modern logic. Now, the first unit that we covered, or last unit that we covered, was chapters 5, 6, and 7 over categorical logic. This is now over a different system of logic. It's called modern logic or symbolic logic. So categorical logic was based on the following idea. You had sentences like this: some textbooks are expensive items. And the way it worked was that we were looking at two different categories of things, like textbooks is one category of things here, and expensive items is another category of things. And then we were comparing those two categories to see how they overlapped. So we might have said some textbooks were expensive items, or all textbooks were expensive items, or no textbooks are expensive items, or whatever. And that led us to 4 different quantifiers: all, no, some, and some not. And every different categorical proposition was phrased in terms of one of these 4 quantifiers and then these 2 different categories. Now, modern symbolic logic works on a very different basis, but it's got sort of the same kind of pattern to it. So with modern logic, we base it not around quantifiers, but around logical connectors or connectives or logical operators. So first of all, here's a sample sentence in modern logic. If today is Wednesday, then we will have class today. Okay, that is a simple example of the kind of thing you might say in modern logic. That's a proposition. It's either true or false, that if today is Wednesday, we'll have class today. And it's based not on quantifiers, all, some, none, or some not, but on one of 5 logical operators. The operator here is called an if-then operator, and that's because you can see that that's what it is because it has an if and a then in the statement. We're going to look at 5 logical operators. They're going to include and, or, not, if-then, if and only if. Most of the time, we'll call these logical connectives because except for the not, the other 4 are all called connectives. Not is technically not a connective, so I'll call them operators when I'm speaking more generally. All right, so first thing then to know is instead of using all, some not, or no, we will be using and, or, not, if then, or if and only if. The second thing is categorical logic focused on having 2 different categories of things and then seeing how they overlapped. This will focus on having compound statements which are built up out of simpler ones. So back here, when we had if today is Wednesday, then we'll have class today, we're taking 2 smaller statements, today is Wednesday, and we will have class today, and we're building them up into a more complex statement called a compound statement. If today is Wednesday, then we'll have class today. Just like compound words are words built up out of smaller words, like houseboat is a compound word because it's built out of the words for house and boat. Compound statements are built up out of simpler statements. So if we start with the simple statement, today is Wednesday, and the simple statement, we will have class today, we can put them together in different ways. If we use an and, we can put them together saying, today is Wednesday and we will have class today. Now what we're going to do throughout this entire thing, this is modern symbolic logic, so we're going to use symbols to represent each of the different sentences in most cases. So here I'm using the symbol P to represent today is Wednesday, and the symbol Q to represent we will have class today. So here's P and Q right there. You can see the 2 smaller statements that are part of the big statement. And then the big statement is an and statement, which takes P and Q and puts them together to make a bigger statement, the whole claim that today is Wednesday and we'll have class today. And I'll call that P and Q. But we're going to use symbols all the way throughout, so the way we'll write that is this. We'll put a dot in between the P and the Q, and that dot stands for and. It looks like a times. It's a dot in the middle of the line, and that will be and. So this is P and Q. There's a name for the and statement, by the way. It's called a conjunction. Okay, let's talk about the other logical operators. A second logical operator is to use the or. Today is Wednesday, or we will have class today. That's different than saying today is Wednesday and we'll have class today. This time we're saying today is Wednesday or we'll have class today. But once again, we have 2 smaller statements, P and Q. And we put them together to make a bigger statement, P or Q. And that also has a way of symbolizing it. You write like a V or a wedge in between them, P or Q. And this is called a disjunction. Third type of statement is simple. It's negation. So this is where we have a statement like P, today is Wednesday, and we simply say the opposite. No, today's not Wednesday. So here, the today is Wednesday part is P, but when we add the not in there, we get something which is called not P, and it'll be written this way. The symbol for it will be that little squiggly thing, the little tilde. And so that's called negation. The fourth type of compound statement is probably the most complicated, but it's probably also the most important, and that's the if-then statement. We take the two statements, today is Wednesday and we will have class today, P and Q, and we put them together with an if-then. If today is Wednesday, then we will have class today. And that full statement is known as an if-then statement, and it would be read if P then Q. This is used very, very often, and sometimes instead of saying if P then Q, I will say P implies Q. That's another way to say this. And in both cases, the symbol for it is to use this little horseshoe symbol. It's like a sideways U. So P implies Q, and this is called material implication. The last thing that we can have is also complicated, but we won't use it very much. And this is something which is called an if and only if. This would be saying today is Wednesday, if and only if we will have class today. And this is this is spoken P if and only if Q. It's written using what's called a tribar, a three-line equals sign. And this is called material equivalence. All right, these are the 5 different operators that we're going to be talking about, and we're going to do a whole bunch of work with these. Of course, right now you probably can't remember any of them, and the symbols will be a little confusing, but this is what we're going to be using for the next 3 chapters. So just for now, just hopefully you understand the 5 operators we've got. We've got an and operator, an or, a not, an if then, and an if and only if. All right, that's it for this video.